going to be a Hemp Fest over here in Fort Myers in January. I'm going to try to have my test done by then.
Okay, perfect. Yeah, it's good to have a goal, goal
Yeah,
to
goal
shoot
cer-
toward.
Well, here we are once again on a Tuesday night for an amateur radio upgrade class to the Amateur Extra. For those who might have your general class or advanced class amateur radio license in the United States, well, we help you get to the final pinnacle, the Amateur Extra. And we've been working through this book, the American Radio Relay League License Manual for the Extra class. And we're going to go through the last chapter in the book tonight, Chapter 11, Safety. So, and then the plan is we'll complete that in the first half of class. We'll take a 5-minute break and come back and take a 50-question multiple choice practice test together and see how well we all did as instructors and as students. So, and you grade your own paper, you don't have to share, so, you know, not to worry. So that's the plan for tonight. Before we get started with the instructional material, I just want to make you aware, if Bruce, come to, there we go. This weekend is the American Radio Relay League 10-meter contest. The URL for the information is down there at the bottom. It's kind of a wordy slide there. But anyway, with your license right now, with an equipment and very modest antennas, you too can participate. There are various categories. You can do CW only, or you can do single sideband only, which is what I'm going to be doing, or you can do both. Mix it up. High power, low power, QRP, all sorts of different categories. So take a look and listen on the bands at least this weekend, because you should hear a lot of activity. 10 meters has been really a strong band. It's been really healthy today, and I think it will be hopefully this weekend if the sun cooperates. And then, as we mentioned prior to class with some of the folks in the Zoom classroom, coming up in February, the 13th through the 15th, is Hamcation. Hamcation is a large ham fest in Orlando, Florida, held at the fairgrounds there, and all of the major manufacturers will be there. You'll see a lot of folks from ham radio celebrities and experts. Rob Sherwood was there last year. I'm hoping he'll be there this year. A bunch of interesting people, a lot of equipment, the newest stuff, a lot of vendors there selling equipment, good deals. So if you haven't considered coming to Hamcation, I highly recommend it. I'm going to be there. Dave's going to be there. Bruce is going to be there. So you all come to Orlando in February, and we'll say hey in person. All right. So as I mentioned, this is the last chapter in the book, and I want to convince you that amateur radio is an adventure. What? I just sit behind my radio and twiddle the knob. Well, okay. What is an adventure? An adventure is one where success is based on your own efforts. Even then, success is not guaranteed. It takes a lot of work and preparation. Oh yeah. It takes an investment in time, effort, and money. And there's an element of danger. And unfortunately, in amateur radio, there is some danger involved. And so in the corporate world, we deal with risk management, trying to minimize problems that you might face. And so some of the hazards in amateur radio that we need to be cognizant of: electric shock, falls from height, radio frequency exposure, chemical contamination, and hazardous materials, all of those things. And as the wife said, oh, what a relaxing hobby, dear, with all of that. So keep in mind that as we go through tonight, we teach the test. And so what we're going to do is we're going to focus on what extra class test takers need to know with regards to safety. That's the one thing about safety, it builds. So the information you learned in the technician class builds with the stuff you learned in the general class and now in the extra class. So all together, it's a pretty good comprehensive overview of safety. But what we're going to talk about tonight are these three areas: climbing safety, radio frequency exposure, and then grounding and bonding. And we'll do all these three in the first half of class, then we'll take our intermission, and we'll come back and do a practice test. All right, climbing safety. As many of you know, I used to work for the Voice of America, and overseas at relay stations. I got my start in Liberia, West Africa, went to Morocco, to Germany, to Sri Lanka. Let's see where else. Oh, and my last overseas post was in Kavala, Greece. And at a VOA overseas relay station, we had these. This was our organization chart. There was the manager and deputy manager, maybe. And then we had the transmitter plant, we had the admin unit, and we had facilities. And under facilities, we had at most stations a rigging crew. This was a group of guys. Their whole job was to climb. And to maintain antennas that looked like this. This is the Radio Free Europe Playa de Pals station, which I visited, but I never actually worked there. But at all of the overseas transmitting stations that had these very large antennas, you needed to have a staff of riggers. Did you know that working on cell phone towers in the United States is the deadliest job? Riggers, have to, be concerned with falls and preventing them. There's a big long, listing of some of the things, some of the hazards that you can have here. At VOA, we had safety rules for antenna maintenance. We had to tell the control room that maintenance was going to go on. At our antenna switch matrix, the antenna was locked out so that you couldn't energize it. Electrical power was switched off. Grounding clamps were applied to the transmission lines. Always two men worked together, never one person. Personal protective equipment had to be for ground personnel and also for climbers with harnesses and lanyards. And even some of our antennas were built with a ratcheting track on their climbing ladders, so you could just snap into that. And as you would go up, it would go up freely, but it wouldn't come down unless you release the ratchet. Well, we don't have all of that in ham radio, but in ham radio, if you're going to be doing antenna work, make sure that you obtain training, that you know what you're doing. One way you can get that is by volunteering to help experienced climbers and see what they're doing. If you're on the ground, the minimum personal protective equipment is a hard hat, safety glasses. Think about this, safety sunglasses, because most of the time if you're on the ground, you're going to be looking up, and you might be looking up into the sun, and so you're going to be doing this all the time to try to see what's going on up there. So sunglasses can be important, and gloves. Two-man rule should apply. Never, never, never climb by yourself. Make sure that there's somebody there that can, be your crew on the ground. At worst case, at least they can call 911. Now, if you're the climber, the rule is you must have an up-to-date safety harness. Did you know that safety harnesses have a expiration date? Yeah, they're rated for your weight. They should not restrict your movement, and you need to have at least 2 lanyards, plus a shock-absorbing lanyard, and a climber's helmet, which is much like a rock climber's helmet. But Mastrant, who's one of the makers of harnesses, they say that their harnesses are good for a period of 8 years from the date of production. After that, you need to get rid of them because they can't guarantee that everything is going to hold up. So keep that in mind. And lanyards look like this, the hook lanyards, so that they clamp on the harness at a D-ring there, and you're able to then take the larger rings and put them on the tower legs as you go up the tower, always keeping one connected to the tower at all times. So that's 100% attachment or 100% tie-off. A lanyard is always attached to the tower. Free climbing used to be a thing, but no, it's not a good idea because that's when problems can happen. The lanyard is attached to the tower leg, not a cross brace. Why? Well, because the leg is really thick around, whereas the cross brace is thinner. You might pull on it, break a weld, and then have a real problem. And once in a position, they say attach a shock-absorbing lanyard, it's a third lanyard, up over your head, as high as you can get it up there, so just in case something happens, it can shock absorb a fall. Now, if you're on the ground crew, What you do not want to hear is one of the climbers or climber up top saying, "Headache coming down." That means they dropped something, probably a tool. So that's where the hard hat comes in. So I'll give you some videos that you can take a look at later. This is one on climbing safety from Valerie Hutzfeld, I believe, her channel. And then here in the Carolinas, Don Dazzo is, I think I forgot his name, K4ZA, is a commercial climber, and he's got information as well. And then, of course, our folks over at DX Engineering have a series on climbing safety. So those are the things, if you think you're going to be climbing a tower, that you want to familiarize yourself with and do the safe thing. Oh, let's answer some questions. Let's see how we do. So keep in mind the 3-second rule. What is meant by 100% tie-off regarding tower safety?
Bravo.
Yes, bravo. At least one lanyard is attached to the tower at all times. And what should lanyards be attached to? What should be lanyards attached while climbing?
Delta.
Delta.
The tower legs, because they're the thicker element. And where should a shock-absorbing lanyard be attached to a tower when working above ground?
Alpha.
Alpha.
You want to take as much slack out of it as possible, so you want to go over the climber's head. That's where the shock-absorbing lanyard is attached. All right, great. On to section 11.2, RF exposure. So handheld transceivers, big radios in your ham shack, everything is subject to RF exposure limits. And the FCC rules related to human exposure came into effect back in May of 2021. And then there was a 2-year grace period before amateur radio operators had to fully comply with all of the standards. They had some general guidelines that they could follow, but now we have to follow all of the standards to make sure that we're considering our safety and the safety of humans around us. Interestingly, I found this is a fascinating rule. Handhelds that were sold before 5/3/2021 are exempt. What's different with their RF than the new RF? I don't know. But the IC2AT from ICOM was a classic radio back in the 80s. And if you still got one of these hanging around, the nickel-cadmium battery is probably flat as heck. But anyway, okay, they're exempt. Radios sold before 5/3/2021 are exempt. So RF exposure rules affect every U.S. amateur, and here is a link to the May 2023 QST magazine. And as of 2023, all transmitters operating in the United States are expected to abide by the FCC exposure rules. You can implement positive access controls, fencing, signage, etc., to prevent access by unauthorized persons. That's one way you can help mitigate problems. And now every station must be assessed for RF exposure before it is operated. And assessment, okay. This is more kind of an informal thing for amateurs because the assessment results are not filed with the FCC. It's best kept in a station's permanent record. You do have a permanent record for your station, right? It used to be your log, but not a lot of people keep a handheld or a handwritten log anymore. But you should have a file. And what they want to show is that you've considered what's going on, the power levels that you're operating, the kind of antennas, and if you add anything new to your station, like a new higher powered amplifier or a new antenna, then you want to run an analysis first so that you know. We'll talk to you about how you do the analysis here in just a second. Why are we doing this? Well, because we have energy that is being radiated from our antennas. And when we talk about radiation, people think nuclear, but that's not what we're doing. Nuclear radiation is what they call ionizing radiation. It can cause chromosomal damage. Whereas radio frequency radiation is non-ionizing, it causes heating in human tissue. But there still can be hazardous, so you just got to keep that in mind. And so you are responsible at your station to maintain a safe RF environment. And you do this through your evaluation, which can be conducted one of three ways. The FCC Office of Engineering Technology Bulletin 65 gives detailed instructions. Computer modeling is the second, and that's the most popular. And then number three, measurement using calibrated equipment, meters and antennas. The antenna and the meter both have to be calibrated. Then the FCC OET Bulletin Supplement B is specific to amateur radio, and there's a URL down there at the bottom where you can take a look at that. You don't have to have a formal written report, but you should notate that an evaluation was conducted, and you promised to do this. Gary, when did I promise to do that? When you went for your license exam, or when you're going for your license exam, look on Form 605 and you'll see the last line there that says that I have read and will comply with the rules regarding radio frequency and RF safety. So that's where you've signed up for this, right there on your application. So here's again the bulletin. This is what it looks like. This is what I suggest. Use the online websites that are available to do the calculations because it's easy and fun. So here's one, an amateur radio RF exposure calculator from hintlink.com, and you can put in information about your antenna and power and frequency, etc., and give you general guidelines. The American Radio Relay League has their own RF exposure calculator. And the URL is there at the bottom. And again, you input information about your station, and it'll tell you how close can you get to the antenna before you're going to be exceeding the exposure guidelines. And then finally, the Lake Washington Ham Club. This is another very popular RF exposure calculator. They're all free. They're all available to you online. It takes just a few minutes to run through and just trying to keep everybody safe. So I talked about maximum permissible exposure, or exposing yourself or others to RF energy. It's specified in the bulletins, etc., and it's also figure 11-1 in the book. And it looks like this. In fact, let's go to the next slide that's a little larger. And so it's based on the way the human body absorbs radio frequency energy. So on the left-hand side, we have the power density level in milliwatts per square centimeter. And on the horizontal scale, we have frequency in megahertz. And if you note that here at low frequency in the 160 meter band, you can, have a fairly high exposure. But as we go up in frequency and we approach VHF, this is VHF in here, that the exposure level goes down. The human body absorbs energy in VHF much more readily than it does at the other frequencies. And so this is the sensitive area right here. 6 meters and 2 meters has the lowest. And notice there's two levels, uncontrolled and controlled. What's the difference? Controlled means people know that there's RF energy being radiated from your antennas. You put up signs that tell them that it's an RF hazard. Or you put up fences to keep people out. Then you can use the higher level. But if it's an uncontrolled situation, it's where people wouldn't have a clue as to, that radio frequency energy might be an issue, like your neighbor's yard, your neighbor's house, things like that. That's an uncontrolled. And so you need to make sure that you keep things below the maximum permissible exposure. And note that it's maximum permissible exposure, not emission. That's the definition of MPE. So if you've got a vertical antenna, always a good idea to put a fence around the bottom. That way people can't access the antenna, can't put their hands on it. They get a very strong RF burn if they did that. That's one way to control your environment. Another, On Amazon, they have these signs. I have them up here at my house. It's a radio frequency hazard notice, just to let people know that there's a possibility of radio frequency energy coming from my antennas. This makes it a controlled area, and therefore you can use the higher levels. So we talked about maximum permissible exposure, and that goes along with the specific absorption rate. That's the rate of RF energy being absorbed by the human body. And as we saw on that chart, different frequencies are absorbed more readily than others. So that's why there's different thresholds. VHF, as I mentioned before, is the most absorbed. So from 30 to 300 megahertz is the area where we have to be the most concerned. So if you've got VHF antennas, really pay attention to this for sure. Multi-transmitter sites. Maybe your club has a repeater and it's up on a mountaintop or something like that. Well, who is responsible? Well, all operators up there are responsible. Specifically, it says any transmitter that produces more than 5% of the maximum permissible exposure. So in general, everybody is, but that's the rule, 5% or greater. If you're going to be putting up links to go from, say, a mountaintop to another mountaintop, those links that you might put up are generally on microwave frequencies. Well, be aware. Microwave antennas, the parabolic dish antennas or other types, tend to have very, very high gain. And high gain antennas, that means that the emitted power level is very, very high. And so you really need to pay attention because high antenna gain equals high exposure levels. So you gotta keep people out of the path, out of the front of those antennas. And you might remember from back in the technician class that our electromagnetic waves are made up of two fields, the electrostatic field, or the electric field, and the electromagnetic field, or the magnetic field. So the E field is the static field, and the B field here is the magnetic field. And you notice they're at right angles to each other. And it's the combination of these two that moves the radio wave along in the direction of the X there you see going from left to right. Well, why do I bring that up? Well, because the human body responds differently to the E field than it does to the H field. And so there are separate maximum permissible exposure limits for each of those, for the E field and for the magnetic field. E and H fields occur at different points. So that's another thing to be aware of. The maximum E field may be a minimum H. So all of these things have to be taken into account. Also, ground reflections, especially around antennas, that will impact E and H fields differently. Okay, we made it to questions. Let's see if we can understand what we're talking about here. All right. So when evaluating RF exposure levels from your station at a neighbor's home, what must you do?
Bravo.
Yeah, so your neighbor's house is going to be uncontrolled, so you want to ensure that signals from your station are less than the uncontrolled maximum permissible exposure. Note exposure, not emission. Over what range of frequencies are the FCC human body RF exposure limits most restrictive?
Charlie.
VHF 30 to 300 megahertz. You're doing great. And when evaluating a site with multiple transmitters operating at the same time, the operators and licensees of which transmitters are responsible for mitigating overexposure situations?
Charlie.
Yeah, each transmitter that produces 5% or more of the MPE limit in the areas where the total MPE is exceeded is responsible. And what hazard is created by operating at microwave frequencies?
Bravo.
Yeah, so the high gain antennas result in high exposure levels. And why are there separate E and H MPE limits at frequencies below 300 megahertz?
Delta.
Delta.
You got it. Yes, all of those. The body reacts to electromagnetic radiation from both E and H. Ground reflections and scattering can have an effect, and E and H field radiation intensity peaks occur at different locations. So all of those. Very good. And what does SAR measure?
Charlie.
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 It is the rate at which RF energy is absorbed by the body. Very good. And which of the following types of equipment are exempt from RF exposure evaluations?
Charlie.
Charlie.
Yeah, so if you got that old ICOM IC2AT, that one is exempt. And when must an RF exposure evaluation be performed on an amateur station operating on 80 meters?
Alpha.
Alpha.
Yeah, you always have to make an evaluation. Then if no changes occur, then you're fine. You can just go with that evaluation. But if you upgrade, if you change antennas or change power levels, etc., you need to perform a new one. Great, excellent. All right, section 11.3, grounding and bonding. This is always an interesting topic. So I say, and this is Gary talking, there are 3 types of ground. Electrical safety ground, this is what the NEC, the National Electrical Code, deals with. It's a life safety. So electrical safety, the green wire in your outlet, that's what that's all about. Lightning protection is another kind of grounding. It protects property. And then there's a third, which is sometimes called signal ground or common reference potential. That's a radio frequency ground that we use to keep all of our equipment at the same potential.
I was supposed to give something. Okay, how about you?
Oh, okay, somebody's been having a conversation there. I thought that was a question. All right, good. So single point AC ground. There should be a ground rod installed at the main breaker panel entering your house, and grounding or earthing limits over voltages from lightning surges and faults by diverting them to the earth through grounding rods. All right, that's the definition. The earth is not an absorbent sponge, however. It doesn't suck lightning energy into the ground. Rather, it's a reference potential. So that's where grounding occurs. It should occur at the main panel per the NEC. That's for safety grounds. Now, if you're going to be installing a surge protector in your house, you want to have the surge protector installed at that point. Because if it's installed at that point, then there aren't going to be any differentials between one building or another, your garage and the house. That's the problem. If you get differentials, then that can cause issues. But if you're going to install a surge protector, you want it to be installed at the single point ground main panel, making sure that all surge protection activates at the same time. You don't want those differential voltages because that can cause equipment damage. So again, the surge protector goes at the main panel. If you've got sub-panels, that's fine. They can be independently grounded, but per the NEC, they need to be bonded together with a wire either between the ground rods themselves or between the panels, so that they're all the same AC ground potential for life safety. Now, in amateur radio, we're concerned if we put up towers, for example, depending on your location, you might get struck multiple times during the year. So the primary purpose in amateur radio of an external earth at towers is lightning protection. The ground rods at the tower base are external grounds. They're supplementary grounds. They're talked about in the NEC. They're not involved in life safety per se, in your electrical panel. Rather, they're there for lightning protection. And actually, the theory is that, okay, if you have a direct strike, yeah, they're going to absorb some energy in the ground. But more importantly, they're going to be there to help dissipate charges that might build around your tower, electrostatic charges that can be dissipated. And you may have seen these on towers, these little brush-like things that come out to a little point, a bottle brush kind of thing. They're there for static dissipation. It allows static charges to go into the brush and then down and to the ground rods below the tower. And by using these sorts of things, you can actually minimize the number of times that a lightning strike will happen directly on the tower. Grounding is really more about lightning prevention as opposed to lightning protection when we're doing this sort of a thing. Now, I mentioned that in amateur radio we use these additional grounds at the tower bases. It's possible you might put additional grounds also at a point where you're doing some antenna switching, things like that. These are what we call supplementary grounds. And in this case, the NEC does have a paragraph on these. The thing is that because they're not involved in AC power distribution or whatnot, you do not need to bond these grounds back to the main panel. Rather, the connecting cables, the shield on the coax, etc., is considered enough bonding to that for these supplementary ground connections. And again, at the antenna tower, it holds the tower at earth potential, and again, the lightning protection is the most important thing. Now, in our ham shacks, we're going to move from grounding to bonding. Bonding keeps equipment chassis at the same radio frequency potential. And I'm all about receiving weak signals. I like to be able to hear the weakest signals. And that a lot of that is all about keeping noise levels down. And you don't want to have different pieces of equipment in your ham shack have different chassis potentials. Not only for AC power, but also for noise levels, because that differential can push noise from one unit to another. So by connecting the ground connections on various pieces of equipment in your ham shack to a common ground, this can help reduce noise levels on receive. Also can help you if you've got antennas that don't have their own counterpoise or grounding system, and they have a tendency to shoot transmitted RF back into the ham shack, which can happen. Then this will help mitigate you from getting any RF burns. So this is RF bonding. Now, I will say this shows this RF bonding going to a bus bar or a ground bar. Actually, the best way to do it is star grounding, to bring them all together to a central point and then have that run out to a ground rod on the outside. As I mentioned before, and this comes from Ward Silver. Ward Silver wrote the book. Come back to me just for a second. American Radio Relay League has this book that Ward Silver, N0AX, wrote on grounding and bonding. It's kind of considered the Bible in the amateur radio community. And the things that he wanted us to know is that the Earth is not a sink into which we can pour RF and expect it to disappear. That's not what RF ground is about. And it's hard to maintain a zero voltage difference over a wide frequency range between equipment. So I said we want to keep all the chassis at the same potential. We can do that maybe at certain ranges of frequencies, but other ranges of frequencies, remember that a quarter wavelength long length of anything is an impedance inverter. So instead of shorting things out, it may actually open things up if the distance is long enough. And then the bugaboo. Ground loops can result when you connect chassis of equipment together. Come back to me just for a second. Bob Heil, who was very influential in our amateur radio community, Heil Sound, the headsets and all of that, he was part of a group of amateur radio operators that were really concerned about ground loops. And you'll hear this, I just want to make you aware that this exists. There is a thought to not ground everything. Okay, the general rule of thumb and the rules from the ARRL and the licensing tests and whatnot says, no, we want grounding. But Bob Heil was more concerned about these ground loops, and he said not to ground things. If you read that someplace, just know that that exists. But bonding here's the reason to do it. It prevents shock hazards and RF burns. It prevents destructive voltage differences caused by lightning surges. It limits the current between devices. For bonding to work at radio frequencies, the connection has to have a low impedance and must be electrically short. So flat, wide copper strap is the best thing that you can connect things together with. Shielded braid is another good one, but it should be no greater than 1/10 of a wavelength long at the operating frequencies. And keep bonding connections short and direct. If you have to use wire, use thick wire, number 12, number 14, and that will keep things bonded together. And the results is that once you've established a bonding system, you should notice that installing new equipment or moving stuff around doesn't cause issues. SWR and other RF measurements should be more consistent. Your transmit audio on voice or digital modes is like to have less noise. If you do experience interference, it will be easier to isolate and find. So those are the benefits of grounding. But I highly recommend Ward Silver's book. It's excellent. All right, last section of the class. Let's see how we do. So what is the primary function of an external earth connection or ground rod?
Bravo.
Yeah, I wish they would have phrased this more specifically. Yeah, at the towers and whatnot, it's lightning charge dissipation. And where should a station AC surge protector be installed?
Charlie.
All right. Yes, indeed, Charlie, on the single point ground panel. Somebody was saying my audio and video sync was out. That's interesting. What is the purpose of a single point ground panel?
Delta.
It is delta, assuring that all surge protectors or lightning protectors activate at the same time. And that, ladies and gentlemen, is the end of chapter 11. But wait, there's more. Because I want you to do better on this practice test than I did. So here's remedial instruction for Gary in ham radio, because I got one wrong. And I thought, what? And Dave covered it, but I didn't listen. So here's a question for you. What is the primary loss in film capacitors at radio frequencies? Film capacitors. These are polyester or styrene film capacitors, mostly used in audio, maybe for some filtering. There are two different kinds. There's the stacked type and the rolled type. And the stacked type here has got the plates that go back and forth, and there's a polystyrene dielectric between the plates. So these are film capacitors. And at audio frequencies, which is what I was thinking, the primary losses through these capacitors are either ohmic, bad connections to the plates, or the dielectric absorbs some energy. All right? So that is true at audio frequencies. But the question wasn't that. The question was, what's the primary mode of loss at radio frequencies? And that has to do with skin effect. So you might remember a skin effect is when radio frequency energy travels through a wire. The energy actually doesn't go through the center of the wire, the higher the frequency you go. It actually goes on the surface of the wire. That's the skin of the wire. It's called the skin effect. Well, on the capacitor, and I didn't know this, but the radio frequency energy forces the energy away from the center of the capacitor plate. And so in this case, the primary loss at radio frequencies for film capacitors is skin effect. Okay, so you can get that one right. Before we take our break, let me give you some final thoughts. We never charge for our classes. Our classes are always free. But we do have expenses, and so if you would like to, it's entirely voluntary, but if you'd like to make a donation to the class to help us carry on our work, buy new equipment or get materials or supplies, etc., there is a donation link at my website, w4eey.com. That uses PayPal. If you don't like PayPal, don't want to do that, you can contact me and I can tell you other ways you can do it. If you're watching us on YouTube, there's a super thanks button. It's a $sign, and you can click on that and maybe send us a couple bucks. That would be helpful. Most importantly, though, if you got a lot out of the class, please tell others. Tell others that we have these free classes available on YouTube and with the Zoom classroom as well for people who participate live. Our next classes will be starting in January, in the middle part of the month. We're going to have a technician class for those who want to get their first license. And then for those who have their technician class and want to upgrade to the general class, we'll have a general class license as well. So technician class will be on Wednesday nights, general class will be on Tuesday nights. And if you're at all interested or would like more information, please just send me an email, w4eey@arrl.net, and I'll be happy to get all the information out to you. Okay, you've been very patient. I appreciate it. Intermission is up next. We'll take 5 minutes and come back and take a practice test together. And we're back. For those of you who are in the Zoom classroom, we had a chat comment that at some point in time my audio and video might have been rolling out of sync. It's not anything we're doing here. It would probably have been a problem with Zoom. I looked at our statistics and we do have a bit of jitter on our video. First time I've seen that parameter go anything other than 0. So sounds like they are having an issue. Also, for those who may have already passed your extra class, congratulations. We're very proud of you. You don't have to take the practice test with us tonight, and we fully understand that's quite all right. If you're looking, though, to take your actual amateur extra class exam, and you don't have a place to take it, let me remind you of these resources. A local amateur radio club, you should check with them and see who's giving the test in your area. You can also go online to hamstudy.org/sessions to find test sessions that might be in your area, or online test sessions if you want to go that way. And the American Radio Relay League Find a Club URL is also another way you can find a local ham club that might be giving the test. And here's what hamstudy.org/sessions looks like. So tonight what we're going to be doing is getting you ready as best we can. We're going to take a 50-question multiple choice test together. And this is practice test number 4. Huh? What? No, this is the first one we've taken together, but we gave this class last year using the same book, and so practice tests 1, 2, and 3 we gave last year, and I've provided them to you as PDFs in the folder from last week's handouts. So you'll find practice tests 1, 2, and 3 there. We'll do practice test 4 tonight, and then practice tests 5 and 6 next week. So there are 602 questions in the question pool, and so you can take 600 and divide it by 50, and you can see how many practice tests you should be taking to try to see all of the questions. But in fact, there's going to be duplications from the tests, so taking a dozen practice tests is not too little. Really, to get you prepared, mentally assured that you've got the material, or to find your weaknesses and to go back and study on those things. So what I'd like you to do is to get out a blank sheet of paper. We'll be numbering it 1 through 50, and then you'll be writing down A, B, C, or D, whatever you think is the right answer to that particular question. Again, these are the actual questions and actual answers that you will see on your test. Just remember, the answers are not going to be in the same order. So do not memorize A, B, C, or D, or you'll be in a world of hurt. For tonight, and when I'm going to bring the test up and you'll be able to read it, I'm not going to read the test question, and so I'll just be watching the video cameras I can see from people. And if you would, when you're done with that question, just kind of raise your hand briefly. That'll tell me, oh, you're done with that. And when I see enough people with their hands up, then I'll know I can go on to the next question. We can also always go back to any questions that we've covered at the end. So if you need to leave something blank, that's fine. We can always go back and check it out. So good luck. You can do this. And here is question number 1. Great. All right, and here is question number 2. If I start going too fast, just let me know. Okay, and question number 3 is a pictorial. What is the purpose of R1 and R2? And question number 4. Okay, and question number 5. And question number 6. And here's question number 7. When you actually take your test, there'll be no time limits, so you can take as much time as you want on a question. But in our TV show here, we move along. And here is question number 8. And question number 9. And here we go with question number 10. And question 11. And here's question 12. And question 13. And now, question 14. And next up, question 15. And question 16. And question 17 is a diagram. What is the 3 dB beam width of the antenna radiation pattern shown? 3 dB beam width. And 18 is another schematic symbols, which is the schematic symbol for the NOT operation. And question 19. question 20. And question 21. And question 22. And here we go with question 23. And question 24. Next up, question 25. And now, question 26. And here we go with 27. And question 28. And question 29. And we can come back to it. Question 30. And now question 31. And question 32. Question 33. And question 34. Here we go with question 35. And question 36. And now question 37. And question 38. And here we go with question 39. And question 40, more schematic symbols. What is the schematic symbol for a Schottky diode? And the question got cut off somehow. How did that happen? And here is question 41. And question 42. And question 43. And here we go with question 44. And question 45. And now question 46. And question 47. Here is question 48. And now question 49. And question 50. And are there any questions you'd like to go back and take another look at? Just unmute and let me know.
Number 20, please.
Sure. There we are.
Okay,
Any others?
thank you.
You bet. Any other questions to be repeated? All right, let's see how we did. I don't have an elegant way to advance through these, so we got to go one at a time. Apologies, make you dizzy there. So how did we do? For the answer, I am going to read the question and the right answer for folks who might be visually impaired. They've waited this long, so we can give them that. So number 1, how can data rate be increased without increasing bandwidth? A, by using a more efficient digital code, 1A. What is receiving directivity factor, RDF? Again, A, it's peak antenna gain compared to average gain over the hemisphere around and above the antenna, 2A. In this figure, what is the purpose of R1 and R2? This is question 3. It's voltage divider bias. Again, A, 3A. 4, what function is performed by a fast Fourier transform? B, converting signals from the time domain to the frequency domain, 4B. And 5, what is the primary function of an external earth connection or ground rod? D, lightning charge dissipation, 5D. And 6, which of the following file formats is used for exchanging amateur radio log data? That's the ADIF file, 6C. And what is the purpose of a single point ground panel? B, ensure that all lightning protectors activate at the same time, 7B. And 8, which of the following can be measured with an antenna analyzer? All of these, a resonant frequency of a tuned circuit, cable length, or cable velocity factor, all of these, so 8B. And 9, what is the phase angle between the voltage across and the current through a series RLC circuit if X sub C is 25 ohms, R is 100 ohms, and X sub L is 75 ohms? Well, we figure out which one is dominant. X sub L is larger, so X sub L minus X sub C is 50, so it's R plus J50, and it comes out to 27 degrees with the voltage leading the current, Eli. 9B. And 10, which of the following frequency ranges is most suited for meteor scatter? That's B, 28 to 148 megahertz. We have you remember 6 meters. That fits in that range. 10B. And 11, to what does the 4 in FT4 refer? It refers to 4-tone continuous phase frequency shift keying. 11B. 12, at what time of day is sporadic E propagation most likely to occur? A, between sunrise and sunset. 12A. And 13, what is the purpose of a step-start circuit in a high-voltage power supply? B, to allow the filter capacitors to charge gradually. 13B. And 14, how is a Smith chart normalized? A, reassign the prime center's impedance value. 14A. And 15, which of the following is most frequently used as a band pass or notch filter in VHF and UHF transceivers? That's the helical filter, 15A. And 16, what is the half power bandwidth of a resonant circuit that has a resonant frequency of 7.1 megahertz and a Q of 150? You take the frequency and divide it by the Q, and you end up with 47.3 kilohertz, 16D. What is the 3 dB beam width of this antenna pattern? 50 degrees approximately, 17B. 18, which is the schematic symbol for the NOT or inversion operation? That's number 5, and that's letter A, so 18A. And 19, what is the function of a decade counter? It produces 1 output pulse for every 10 input pulses, 19D. And 20, what is the purpose of the preselector in a communications receiver? B, to increase the rejection of signals outside the band being received, 20B. And 21, what is the required transmit frequency of a CW signal for channelized 60-meter operation? We always want to keep it at the center frequency of the channel, so 21A. And 22, what impedance does a quarter wavelength transmission line present to an RF generator when the line is shorted at the far end? It presents a very high impedance because it's an inverter at that length, 22C. And 23, what aspect of an analog slow scan television signal encodes the brightness? That's a tone frequency, a specific tone frequency, 23B. And what does VOACAP software model? It models high frequency propagation, 24D. And 25, what does the impedance 50 minus J25 ohms represent? It represents 50 ohms resistance in series with 25 ohms capacitive reactance, 25C. And 26, which of the following is used to shunt feed a grounded tower at its base? You would use a gamma match, 26A. And 27, what does the MDS of a receiver represent? The minimum discernible signal, 27C. And 28, what is a folded dipole antenna? It's a half-wave parallel wire connecting its two ends. That's one way to look at it, 28B. And 29, what determines the PEP to average power ratio of an unprocessed single sideband phone signal? It's the speech characteristics, 29C. what is the effective isotropic radiated power of a repeater station with 200 watts transmitter output power, 2 dB feed line loss, 2.8 dB duplexer loss, 1.2 dB circulator loss, and 7 dBi antenna gain? So don't worry about the isotropic, that's canceled out, and it's just math on the dBs. You add the losses 2 and 2.8 and 1.2, and then take 7 from that and end up with a dB number which is going to be greater than 200 and less than 400, or 252 watts, 30C. Amateur stations may not transmit in which of the following frequency segments if they are located in the contiguous 48 states and north of line A. You might remember that's a line that runs through Michigan. It's 420 to 430 megahertz, 31A. And 32, how do ferrite and powdered iron compare for use in an inductor core? Ferrite cores generally require fewer turns to produce a given inductance, 32C. And 33, what is the maximum permitted transmitter output power when operating a model craft? 1 watt, 33A. And 34, who is responsible for the proper conduct and necessary supervision during an amateur operator license exam? Each and every administering VE. Each administering VE, 34D. And what is the modulation index of an FM phone signal having a maximum frequency deviation of 3,000 hertz either side of the carrier frequency if the highest modulating frequency is 1,000 hertz? Big number divided by the small number, 3, 35B. And what do the subscripts of S parameters represent? They represent the port or ports at which measurements are made, 36A. And 37, why should effective radiated power be limited to a satellite that uses a linear transponder? To avoid reducing the downlink power to all other users. Don't be a power hog, 37B. And 38, how can 2 linearly polarized Yagi antennas be used to produce circular polarization? D, arrange 2 Yagis on the same axis and perpendicular to each other with the driven elements at the same point on the boom and then fed 90 degrees out of phase, 38D. And 39, how is positive feedback supplied in a Colpitts oscillator? D, through a capacitive divider, Colpitts capacitor, 39D. And in this figure, what is the schematic symbol for a Schottky diode? And I apologize, I got cut off on the question. It is number 6B, 40B. 41, what are some of the differences between the Baudot digital code and ASCII? Remember the magic number 5? Baudot uses 5 data bits per character. ASCII uses 7 or 8. Baudot uses 2 characters as letters, figures, shift codes. ASCII has no letters, figures, shift code. 41C. Here's the one I got wrong. What is the primary cause of loss in film capacitors at RF? Skin effect, 42A. 43, what is the beta of a bipolar junction transistor? It's the change in collector current with respect to base current in a common emitter configuration, but 43C. And what does the packet path wide 3-1 designate? It's 3 digipeater hops are being requested with 1 remaining, 1 left to go, 44A. And 45, which type of detector is used for demodulating single sideband signals? In a conventional superheterodyne radio, that would be a product detector, where you have a beat frequency oscillator that comes in, so 45B. And 46, what frequencies are authorized to an amateur station operating under RACES rules? all amateur service frequencies authorized to the control operator. That sets the limits. So 46C. And 47, which of the following component package types have the least parasitic effects at frequencies above the HF range? Well, it's surface mount devices. They have short leads. 47B. And what is an operational amplifier? D, it's a high gain, direct coupled differential amplifier with very high input impedance and very low output impedance. 48D. 49, what happens to the photoconductive material when light shines on it? Resistance decreases. 49B. And 50, which of the following is required in order to operate in accordance with CEP rules in foreign countries where permitted? This is in Europe. D, you must have a copy of the FCC Public Notice DA 16-1048 along with your license and identification passport. The notice that's in 3 languages, so 50D. So how did you do? Are there smiles? There should be. If you had no more than 13 wrong or 37 correct, you passed. I'm seeing some smiles. I'm happy to, yeah, thumbs up, great, excellent. Well, that is it for tonight. Are there any comments or questions before we go? You want to remove the spotlight there, Dave? Yeah, thanks.
Thank you very much. I really appreciate it. This has been really helpful.
Absolutely. So the plan is for next week, and it's entirely voluntary, it's up to you, but we'll do 2 more practice tests like we did tonight if you'd like, because I want you to be taking practice tests and get comfortable with the material. I want to thank you all for being great attentive audience, and it was fun for me to watch you guys and raising the hands and everything tonight, and seeing the smiles on people's faces. Steve, did you have a question?
I do. On that website that you mentioned in the email, is that just like you just got to log in again to the ARRL site?
This is for the Learn website.
Yeah.
Yeah,
This is for the test website. The practice test.
The exam review website. Yes, you
Yeah.
log in with your account information that you established, whatever you set it up. If you haven't set up an account with them, they'll ask you to set up a new account. You're giving them an email, and you set a password for yourself. That's just so that they can keep track of who's using it, and they can give you the right information back.
I do. Okay, thank you.
And I'll provide a link to that again in an email tomorrow.
And it's free, by the way. You don't have to pay for the testing site. Even if you're not an ARRL member, it's
Correct.
still free service.
All right. You've done great. I want you to take a moment just to reflect on that big book and that you looked at it the first time and you go, hokey smokes, what am I getting involved in? And you're here. And I'm so proud of all of you. And so with all my best wishes, let me say, until next week, if you want to come on back, 73, and we'll see you next time around.
Yep. Thank
Ciao,
you.
ciao.
Thank you.
Thank you.